just to get you to think in regards to outside the box in regards to math. Where do we find math? Okay. Like any other concept, big concept that we arrive to, I always introduce it with in a little different way so you guys can see the relation. Okay. So let me show you a quick video. Here we go. Lights, please. So you've probably seen these before. You gotten into some of these. Watch. You know that anticipation before you get to the top, you're like, oh yeah, right there. Ready? Here we go, here we go. Ready? And it goes slow right there so you can get in the little rail thing. Here we go.
We have to do this all over again.
Here we go, here we go.
I see a lot of water. Here we go. Swooshy.
That's not right there. Okay, lights, please. So pretty much, guys, everyone's been in one of, well, hopefully most of us, right? And believe it or not, those require a lot of math to construct. Yes, watch. Let me show you some pictures. Look at this one. Here's one. Here's another. And for those of you that don't see it, watch. When we did linear equations, the graph of linear equations, do you guys see here, everybody look up, right here, there's a vertical line. There's a horizontal line. Horizontal lines here, vertical lines. But then if you want to get lines with positive slopes, you guys see this one right here? Positive slope, positive slope, positive slope. And these diagonals going down are negative slopes. You guys see that? So all that could be done with graphing and linear equations. However, the only one we haven't been doing is, by looking at this picture, what would be the one thing that we haven't addressed? The curve, right? You were introduced to this last year, but this year we're going to get more into these kind of equations. That's why today's topic is quadratic functions, okay? But I just wanted to show you where those are found. So check this out. For those of you that don't see it, here it goes. You guys see where it comes from? Yeah. So that's how we can use all the math that we've learned so far and apply it to designing something like that. I know there's other things that go into play, such as physics, such as calculus. There's other things that are needed to calculate those roller coasters. However, but the basic foundational math is what? Algebra. Everybody with me? So therefore, today's objective, here we go. I can graph a quadratic function and determine whether a point is on the graph of a parabola. I can graph a quadratic function and determine whether a point is on the graph of a parabola. Let's read together. 1, 2, 3. I can graph a quadratic function and determine whether a point is on the graph of a parabola. So from now on, when we look at the graph of a quadratic function, whenever you hear quadratic function, and when you're thinking about the graph, from now on it's called a parabola. 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 So anyways, who's seen those of you that live around neighborhoods that they have those dish satellites? the satellite dishes. When they first came out, guys, a long time ago, in a galaxy not too far away, they used to have those satellite dishes. They were about the size of, let's see, about the screen. The entire screen. They were huge dishes, and they were called parabolic dish. Parabolic dish. Think about it. Why? Because it becomes a curve, a parabola. Exactly. That's where they get it. Everybody with me? All right, here we go. Yeah, there's still some. If you look around and you go see that there's some antennas that are satellite antennas, the old kind. They have it looks like a little drum, but inside, instead of being flat, the drum being flat, it goes in. That's a parabolic satellite or a dish, parabolic dish. Yeah. Yes. What it is, the dish here. Let me draw it here so you guys can see. Watch. The dish looks like this. Okay, and this looks like a parabola, doesn't it? Okay, so here's a dish, and here it has, I think it has like a triangular thing like this, and then it's got a receiver. So this is what happens. The satellite that's up in the air, let's say here's the moon and the stars way over here, all this, and there's a satellite, you know, rotating the earth and spinning and stuff like that. So it sends a signal. When it sends a signal, this dish, since the signal's going like this, notice that it's curved. It curves so that all the signals, when they bounce here, they go in here. Doesn't matter where they bounce. You guys see that? So that's why the antennas, the satellite antennas, they're parabolic, so that anywhere the signal comes in, even if it comes way over here, guess where it's going to bounce to? The center. It's going to bounce to the center like that. And that's why they make them parabolic. And this is what the signal comes in here, and all of a sudden that has a transformer, whatever it is. The cable goes into your home. In your home, it's got a receiver. The receiver translates the data, and that's what becomes your movies and images. Okay? All right, here we go. Write these concepts down. Quadratic function. A quadratic function is a two-variable equation where the highest degree is 2. Quadratic function, a two-variable equation where the highest degree is 2. Quadratic function, two-variable equations where the highest degree is 2. Quadratic function, two-variable equations where the highest degree is 2. Example, y equals x squared and f of x equals 2x squared. Looks very similar, doesn't it? Y equals x squared and f of x equals 2x squared. And now some of you are like, we've seen this before, didn't we, Mr. Q? Yeah. When we covered linear equations, remember? And then we got into linear functions, remember that? Either with a domain, and what is a domain, what is the range, and all that. Is it a function? And I said, I'm going to exchange, everybody look up, the y, the variable, and I'm just going to write f of x, because this means function of x, remember? Function. So that's why everything looks the same except for this part. You guys see that? Look at this next example. Y equals x squared plus 2, and this one is f of x equals x squared plus 2. Why? Because it's indicating that it's a function. It's a function. Next one. Y equals negative 3x squared plus 1, and this one is f of x equals negative 3x squared plus 1. Non-examples. Y equals 3x plus 5, and y equals x cubed plus 9. So according to the definition, two variable equations, highest degree of 2. Two variable, highest degree is a 2. Two variable, highest degree of 2. Two variable, highest degree of 2. And these, like I said, they're exchangeable because instead of y, we just wrote f of x, f of x, f of x. Are we there? Think about it. Why are these non-examples? So, talk it over with your neighbor. Why are these non-examples? So I heard that because all these have exponents of 2, and this one is a 3, and this one is a 1. So the most important thing to remember is that they are 2 variables, and the highest degree is 2. Copy that, please. Okay, so for this lesson, since we're graphing, think about it. What was our first step when we got to graphing? Tell your neighbor, please. Solve for y. That is correct. Write these steps down, please. Oh, actually, before I move on, everybody look up, please. Pens down. So now, as we go back, when we finish with functions, let me show you the difference between just a function, quadratic function, and a quadratic equation. Look up, please. Function, equation. Function, equation. Function, equation. Function, equation. For those of you that haven't seen it, a quadratic function includes all these that say f of x. A quadratic equation does not. We just have y equals to whatever. Everybody with me? Okay, let's move on. Steps. Here we go. Step 1. What did we say step 1 was? Solve for y. But if you want to write the entire thing that it says here, that's fine. It says make sure the function is in y form, or solve for y. Step 2, build an input-output table and add a domain of -2 to 2. Step 3, substitute values into the function and find the range. Step 4, plot your order pairs and graph the function. Step 5, check if a given point is a function by substituting. Copy that, please. Okay, once again, 5 steps. First one, solve for y. Step 2, you're going to build a table. Domain -2 to 2. Step 3, substitute values into the function and find the range. Step 4, plot your points and graph your function. At the end, we're going to check if a point is on the function. Are we there so far? Okay, on your graph paper, copy this down. Example number 1. On the graph paper, let's do this one on the big one. Here we go. It says, copy this, please. I wrote the steps up here so that I can check them off to make sure that you're following along. But write this, example 1, and it says graph y equals 2x squared, and check if 2, 1 is on the function. Copy that, please. All right, here we go. It says graph y equals 2x squared and check if 2, 1 is on the function. So let's start with the graph. What did we say step 1 was? Solve for y. Is this already solved for y? Yes. Step 2, build an input-output table. So draw your input-output table. I'm going to draw it on this side, x and y, in the domain -2, -1, 0, 1, and 2. Bless you. Bless you.
I didn't get it.
All right, here we go. So let's rewrite our function, but instead of x, I want you to open up a parenthesis, because we're going to substitute values in there to get our table filled. Here it goes. I'm going to rewrite this. Instead of x, we're going to open parentheses. And what is our first value that goes in there? -2. So we bring -2 over. And if we use order of operations, we do the exponent first, right? This means -2 squared. What does that mean? -2 times -2, which is 4. So what is 2 times 4? 8. And that goes in there. Are we there so far? What would be the next one? So we do the same. Oh, and by the way, I plotted my point already. Everybody look up on our graph. -2, 8. Do that, please, and label it for your order pair. Okay. Here we go. Next, I'm going to substitute -1 in there. So -1 squared. What is -1 squared?
1.
1. So that leaves us with 2 times 1. What is 2 times 1? 2, and that goes right there. Plot your point. -1, 2 is about right there. Label it. -1, 2. Next, substitute 0. What is 0 squared? And 2 times 0? So that's 0 there, and that's our point of origin. We plot our point right there. Label it 0, 0. So far, so good? Next one, substitute 1 in there. What is 1 squared? 1. So what is 2 times 1? 2. That goes there. And we plot our point. 2. It's 1, 2, which is right there. And you label it. And the last one, we're going to substitute the number 2 in there. What is 2 squared? 4. So therefore, this is 2 times 4, which is 8. And that's our last point. Plot that 2, 8, and label it. And then your graph is going to be a curve, not a V, a curve. You're going to curve like so. And that's pretty much the homework, guys. All you have to do is practice graphing quadratics. That's all it is. The only thing, I have a couple of vocabulary I want to cover with you. Everybody look up, please. Yeah. Check this out. The first one, I want you to point to the graph or the function, and we're going to label that a parabola. And I already explained to you where they used it before, right? Or where they use it. Roller coasters, they use it also for designing dishes and stuff like that. That's why they are called parabolic antennas. There it is. The other piece that I want you to label, ever look up, I want you to circle this spot. If this was a roller coaster, isn't this the lowest part? This is called the minimum. Minimum. Others call it the minima with a here, minima, but we'll call it minimum. However, check this out. So here's a roller coaster coming this way, then it goes up, and then all of a sudden it hits a peak like this. So guess what this is called? Maximum. So notice this. When it's like this is called a minimum. When it's like that, this is called a maximum. You don't name the curves. We name the point. The lowest point is the minimum. The highest point of the curve is a maximum. Okay? All right. Next. Are we done graphing? Yes. But now it says check to see if 2, 1 is on the function. So I want you to rewrite your equation, but instead of x, you open up parentheses, and instead of y, you open up parentheses. So check this out. It should look something like this. So, where do we get those values? Let's see. What is x? 2. What is y? 1. So this is 1, and this is 2. Does everybody see where I got them from? So let's see. What is 2 squared? 4. What is 2 times 4? 8. Is 1 equal to 8? No. So then we write not on the function. Not on the function. Now to prove it, let's graph it. 2, 1. 2, 1 is about right there. Everybody with me? So, what does that mean? It means that this point is not on the function. If I was to substitute that in there, this wouldn't be a function. It wouldn't be functioning correctly. Now, how can you remember that? Let's see. So imagine here's your roller coaster, right? And you're well on your roller coaster. Let's say the one at the front is Santos. Santos is at the front, but all of a sudden he hits here, and then this is not functioning correctly, and here he is now. Is he on the function? No, he's not on the function anymore. So, anyways, any questions with this? Fairly simple? Let's do one more. Get on the other graph, please. Copy this. Example 2. Here it goes. Example 2. Copy this down. It says graph y equals negative 2x squared, and check if 1, 1 is on the function. So let's see, what is our first step? Solve for y, it's already solved. Step 2, input output table. So let's see, get your input output table, there it is. Negative 2, negative 1, 0, 1, and 2. And once again, you rewrite your function, and instead of x, you open a parentheses. Are we there so far? So what is our first value? Negative 2. What is negative 2 squared? 4. Y equals negative 2 times 4. What is negative 2 times 4? Negative 8. That goes here. And let's plot that point. Negative 2, negative 8 is down here. Everybody see it? Down here. Okay. Next value. Negative 1. Substitute that in there. So what is negative 1 times negative 1? Positive 1. So what is 2 times 1? Negative 2 times 1, that's negative 2, and that goes right there. Just graph that. Negative 1, negative 2 goes there. Label it. Next one, bless you. 0. What is 0 squared? 0. 0 times negative 2, 0. And that's our point of origin. There it is. Label it. Are we there so far? Let me move this to this side. Okay. Next one. 1 goes in there. What is 1 squared? 1. And what is 1 times negative 2? Negative 2. It goes in there. Plot that. There it is. And the next one. 2. What is 2 squared? 4 times negative 2. Negative 8. That goes there. And there's my point right here. So there's my curve. What is that curve called? A parabola. Okay, parabola. What is this point called? Maximum. Now check this out. If we check this one, let's see, let me do that. I'm going to check if 1, 1 is on that function. 1, 1. This is 1 squared is 1. 1 negative 2. Is this true? Not on function. Have a seat, please. 1, 1 is about right here, and in a good way to remember that it's not on the function. Right here, 1, 1. Right there. There's Santos. There you go. Anyways, check this out before you leave. A couple of things that I wanted to show. Pens down, eyes up here. Sit down, please. If I was to give you another function, watch, such as this one. Do you guys notice that this has a plus something? Yes? So check this out. If I was to do the whole thing, the table and all that, the graph, the points, and my curve. Pay attention, please. Watch. Where does it cross the y-axis? At 2. And what is this? Remember when linear equations, the last part was our y-intercept? So what if this was negative 5? Where will it cross? Negative 5. So check this out. So my homework for tonight, It's found on page what? 548. Numbers 1 through 27 odds. Have a good one, guys. Get those party signs. See you guys tomorrow.